I love math, math, math. Math can change the world. I love to factor. I like the box method. Don't miss a Mr. Ing video.
Alright, let's go over 1.34 equate complex numbers. And before we do that, let's talk about complex numbers themselves. What is this wonderful math family? I'm going to draw a chart. Okay, in this family there are what we call complex numbers. And that is in the form of a plus bi. Now, when b real numbers, when b is equal to 0, there are kind of like two regions. So I have this green region, and we'll call this a gray region, and then alright, so we have something called I'll call it Q. It's just a letter, but rational numbers. Something like 1/2. Okay, within rational numbers, or on this other side, in the gray area, then you have something called I for irrational numbers. Like pi. Pi is irrational because it just keeps going on forever. Alright, within rational numbers, you have a family called z, which is integers. And within integers, you have something called W for whole numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then within this, you have something called the N, which is natural numbers, which includes 0. Okay, on the other side, if b is not equal to 0, and you have something called imaginary numbers, and in here you just have a family. Let's use a different color. Then you have something what we talked about was called pure imaginary numbers, when a is equal to 0. Okay, so that's just a little bit about complex numbers. Okay, let's look over here and do this example with me. Find the value of x and y that makes each equation true. So this is the equation they're going to give us. 5x minus 7 plus y plus 4i equals 13 plus 11i. Okay, so I'm going to highlight this. Hopefully you can see this. The part that has no I in it is this part over here in green. Okay, so that is equal to this part. Okay, so we're going to write an equation, 5x minus 7 equals 13. And the part that is the imaginary parts is here in blue. Well, how do I know that? It's right in front of the I, because I stands for imaginary. and that is equal to this one here in blue. So I have y plus 4 equals 11. And all you have to do here is just solve. So remember, use PEMDAS backwards. So let's write that. PEMDAS. You're going to simplify, and then you go up to solve. So that's why I'm doing adding and subtracting first. So 5x equals 20, and then you just do division and multiplication. So if I divide by 5, x equals 4. Okay, over here, do the same thing, just subtract 4. And we're going to get y equals 7. And for you to check your answer, which you don't have to, but just try to help you understand. If I put a 4 here.
Geometry.
And for y, I put in 7. You'll get 20 minus 7, and this one becomes 7 plus 4i, and then you got oh, I did a bad thing right there. It should have been here in parentheses. So that'll become 7 plus 4, which becomes 11i. And over here, 20 minus 7 gives you 13. So I'm just trying to show you like why you're solving for x and why you can put it back into the equation and it makes it true. Okay, so down here, questions 19 and 24, skip 3 and same directions. Find the values of x and y that make each statement true. Go ahead and press play if you'd like to see me do it step by step. Alright, let's go ahead and highlight the parts that are the same. So in this problem, this one has no I, and this one has no I in it. So I can do 9 equals 3x. So we get x equals 3. And you do this part now. Pay attention. I'm not doing, I know it's the imaginary part, but I'm taking its coefficient, what goes in front. You see that? If I divide by 4, we're going to get y equals 3. Okay, let's try number 20. So here I have x plus 1. And this is the part that doesn't have I. And if you need to, you can always start with the part that does have I. And this is a -6. So that'd be 2y equals -6. There's multiplication. The opposite is division. That equals 1, so y is equal to -3. Okay, looking over here, I have x plus y equals 3, and we subtract 1, and we're going to get x equals 2. Let's try 21. Again, you can start with the I if that helps you. So 3 minus y equals 6. And let's just solve that one. So what would I do? I would probably just subtract 3. -y equals 3. Remember, that's like an invisible -1, so I would divide -1 on both sides. Y equals -3. Okay, this whole portion over here has no I, and that equals to the real part. So that would be 2x plus 7 equals -4. And again, use your PEMDAS. So I'm going to use addition and subtraction first. I'm not going to divide here. So I would subtract 7. It's going to be 2x equals negative 11. Divided by 2, and you're going to get x equals negative 11 halves. That negative sign goes with the fraction line, and it's up and down. Alright, question number 22, same thing. Let's highlight the imaginary part first. So that goes in front of the I. In front of the I. And then you just get to solve a linear equation here. So add 7. I get 3x equals 4. Divided by 3, I get x equals 4/3. Over here in blue, it's the part, all of it has no I in it. So 5 plus y equals 9. I'm using the opposite, so this is positive 5, so I'm going to subtract 5. And I get y equals 4. Let's try question number 23. You can focus on the part here. This one has no I, no I. So if I divide by 5, I get x equals 4. If I do everything in front of the I, I'll get negative 12 equals 4y. And divided by 4, we'll get negative 3 equals y. Okay, so again, put the one in front of I. So negative 16 equals negative 2y. There is multiplication there, so the opposite is division, so divided by negative 2. I'm going to get y equals 8. Okay, so over here, I just have x equals 3. And that would be my answer.
Mr. Math Inc. I love math. The 10 Commandments of Math. Commandment number 1. Thou shalt not write thy math papers in ink. Make sure to obey all of the 10 Commandments of the law. Peace.